In OSI reference model, we have 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Now we will see how many layers are there in the TCP IP model by just having a comparison with the OSI reference model. So we have 4 layers in the TCP IP model. So this side is the TCP IP model. So we have network access layer, internet layer, transport layer, and application layer. The TCP IP protocol suite was actually developed prior to the OSI model, and therefore the layers in the TCP IP protocol suite do not exactly match with the OSI model. The functionalities of the physical layer and data link layer are combined into a single layer called network access layer. The network layer's equivalent in the TCP IP model is internet layer. The transport layer is the same, and the functionalities of the session layer, presentation layer, and application layer are merged into a single layer called application layer. Actually, TCP IP model was developed prior to the OSI model. So this is the actual implemented model, and this is just a reference model, just a guidelines. In some books, TCP IP model is shown with 5 layers. So no problem whether it is a 5-layered architecture or 4-layered architecture, the functionality still remains the same. If you want TCP IP model with 5 layers, just break this network access layer into physical layer separately and data link layer separately. There are some protocols that are there in every layer of the TCP IP model, because that protocol only does the functionality of that layer. If you take network access layer, point-to-point protocol, simply PPP. Frame relay is very popular in network access layer. Ethernet is a very popular protocol in the network access layer. And coming to the internet layer, we have IP protocol. IP means it's simply IPv4 or IPv6, ICMP v4 and ICMP v6. In the transport layer, we have TCP and UDP. In the application layer, we have HTTP, DNS, DHCP and FTP. It's quite difficult to understand all the protocols now, even the expansions, but let it be as such. Anyway, we are going to talk about these protocols elaborately in the entire course. So no worries, for time being, we will just have the expansion of this protocol and the basic working of these protocols. Now we will see the actual TCP IP model. So the TCP IP model has 4 layers. Network access layer, so it controls the hardware because physical layer is a part of network access layer. So it controls the hardware devices and media that make up the network. And coming to the internet layer, this is the network layer actually. So it determines the best path through the network. And coming to the transport layer, it supports communication between diverse devices across diverse network. Simply, transport layer deals with process-to-process communication. And coming to the application layer, this layer is actually dealing with the users. So representing the data to the user plus encoding and dialog control, simply the functionalities of application layer, presentation layer and session layer are combined into a single layer. Now we will see the TCP IP protocol suite. So the network access layer has protocols like point-to-point protocol PPP, Ethernet protocol. It is a very popular protocol for LAN technologies. To be precise, wired LAN technologies. And there are many interface drivers that work on this network access layer. And coming to the internet layer, the routing protocols will come in the internet layer. We know very well, router is a device that works with the network layer. Routing protocols like RIP, OSPF, EIGRP, BGP. We will talk about these protocols elaborately in the network layer part. And we have IP support protocol like ICMP and NAT, network address translation. And coming to the transport layer, the widely used transport layer protocols are TCP and UDP. TCP means transmission control protocol and UDP means user datagram protocol. So any application will use either TCP or UDP. We will talk about these protocols, transport layer protocols, in the upcoming lectures in the network layer part. And coming to the application layer protocol, we have domain name servers or domain name system. That is the name system. There are host configuration protocols like BootP or Bootstrap protocol, dynamic host configuration protocol or simply DHCP, and we have email related protocols like simple mail transfer protocol SMTP, post office protocol or simply POP, or internet message access protocol or simply IMAP. And we have file transfer protocols like FTP, file transfer protocol, and trivial file transfer protocol. And to access the web or web pages, we have HTTP. So these are the popular protocols in the application layer. This is the TCP/IP protocol suite. Now we will see what is PDU, that is Protocol Data Unit. Protocol data units are named according to the protocols of the TCP/IP suite. It means the PDUs can be data, segment, packet, frames and bits. If you don't understand anything, just see this. Whatever the user generates, that is from the application layer, that application layer information or that application layer PDU is called as simply data. So application layer PDU are simply called as data. With application layer data, we will be obviously adding the transport layer header or transport layer information. So once the transport layer information is added with the application layer data, we will call that as segment. So the transport layer PDU is called as a segment. After adding the transport layer information, we will be adding the network layer information. Once the network layer header is added, we will call that as packet. So the network layer PDU is called as a packet. Now with this network layer, we will be adding the data link layer part, that is the header and the trailer. So with the packet, we will be adding the header and the trailer in the data link layer. After adding the header and the trailer to the packet, the data link layer PDU is called as a frame. Now these frames are converted into zeros and ones in the physical layer. So the physical layer PDU are called as bits. The application layer PDU is called as data. The transport layer PDU is called as segment. The network layer PDU is called as packet. The data link layer PDU is called as frame. And the physical layer PDU is called as bits. We will see an example now. So in this example, there is a user who is accessing a mail server somewhere in the internet. So there is a mail server. Let's assume this is gmail.com. He has opened gmail.com in his browser and he is generating the application layer data. So this email data, whatever he is generating, is simply called as data in the application layer. So we can say the application layer PDU is called as data. If it is a big data, obviously it is broken into smaller pieces. Now each of these smaller pieces are added with the transport header in the transport layer. Transport layer PDU is now called as a segment. Now this segment, this is actually the segment. So with this content, we are going to add the network layer header. After adding the network layer header, we will call this network layer PDU as a packet. Now with this information, we are going to add a header and a trailer in the data link layer. This data link layer PDU is called as a frame. Now this frame is a medium dependent frame. Why? Because if this is an Ethernet cable, this frame is going to be different. If it is a Wi-Fi frame, it is different. So Ethernet frames are different and Wi-Fi frames are different. And that's why the frames are medium dependent. And finally, the data link layer information are converted into zeros and ones. So the physical layer PDU are called as bits. So application layer PDU are simply data, transport layer PDU, segment, network layer PDU, packet, data link layer PDU, frames, and physical layer PDU, bits. We will understand the significance of these terms like data, segment, packet, frames and bits in the upcoming lectures. There is an activity for you. Identify the correct layer PDU pair in the following. So the layer and the PDU name is given. So we are required to identify the correct layer PDU pair in the following. 4 options are given: option A, option B, option C and option D. Pause this video for a while and find out which is the correct layer PDU pair and post your answers in the comment section. And that's it guys. I hope now you understood the TCP/IP protocol suite. We compared the OSI and the TCP models. We understood the list of protocols in the TCP/IP protocol suite. And we know about the protocol data unit, that is data, segment, packet, frames and bits. I hope the